Okay, so in the last part, we talk about some simple example. Using this example, we can have a better understanding about, let's say, if we have this piece of data, can we use a model to solve the problem? Okay, so we can take a classification problem as an example to illustrate what's going on starting from the very beginning to the end. Okay, so we think about, let's say, if we, for instance, for this course, right, for this data science course, right, probably you care about the final grade, right, after 1.5 months more, right? Okay, so how to give a good prediction, right? So the first is to we rely on a few steps, right? So we can collect data. Okay, then we make assumption, then find out a representation for the data that we collect, and then we build a model. Okay, after that we do some evaluation, and in the end we see that can we get a better model, yes or no, right? Okay, so what kind of the, data we have, right? Think about that, say, maybe for different students, right? Peter and David, right? So in the past, okay, so they probably also took this course before, right? Maybe machine learning, maybe data science, right? So they get different grades, right? And also they also took some other courses, right? That they also get the different grades, right? Okay, so now here comes our class, right? For students like you, right? You also took the same course one and course two, right? Like Peter and Debbie, right? But you don't know your grades on this course, right? Okay, so the answer is that if we can build up the relationship between course one, course two, and data science or machine learning, right? Maybe given some of the grades that you have for course one and course two, right? Maybe we know what kind of data science or machine learning grades that you're going to receive in the end, right? So this kind of data, right? Actually, we say two parts, right? One is the training data, right? Where that we have, something that we consider features, right? And also something we consider label information, right? For the test data, everything remains to be the same except that we don't have the label information. Okay, here there's a question mark. That's the place that we want to find out. Okay, when we collect the data and we're going to make assumptions, okay, first of all, maybe we need to make sure that, okay, the course will be taught for the from the same instructor, right, like me, right? Okay, I suppose I teach the same course many years, right? Then maybe you can assume that I roughly give the similar grades for different year along different years, right? And also maybe you also assume that maybe different student they perform independently, like, okay, maybe for this course, right? Suppose that we don't have a project when more than just one people get involved, right? So then each student may have their homework and the exam and the project done independently, right? Okay, that's another assumption. And in the end, we're going to collect the data and then make it to be readable from computers, right? Like, okay, for student, take the course one, course two, right? They are going to uh, record it like different features, okay? X1 up to N different courses, right? And also the data science or machine learning grade in the end. That belongs to the training data. And also for this course, right? So we are going to have another group of students, right? They also take the same courses of before, right? Like from X1 up to Xn, right? But of course, probably different feature value, right? But in the end, So we don't know the label information, right? So called the test data. Okay. So how to find a good representation? So here is this could be art, right? We can just simply make it to be ABC, right? So that's the grades that we are going to have, right? Or maybe we can also make it to be numerical, right? ABC can also be make it to be numerical, like A is like a 4.0, right? C could be 2.0, B could be 3.0, that kind, right? Or maybe we can get better finer scale, like a row score maybe, right? So it depends on what kind of input that you want. The result could be slightly influenced by this kind of representation. No matter what, the computer must be able to understand this kind of information to build models. Okay. So in the end, after we receive bunch of data, right? So we are going to we try to build the relationship between x and y, right? So then we are going to try all kinds of methods or machine learning methods or data science methods, right? So here that we can just try something very easy like a nearest neighbor. Nearest neighbor means that, okay, for any x, let's say if we want to predict its y, right? So any x that already took the course 1, course 2, right? So if we want to find out his or her data science or machine learning grade, right? So we can just try to search for some students, some other students in the training set, right? Xi could be more than just one, right? Could be just one. Okay, maybe we try to find the closest student to have the similar features like X, such as maybe if we want to find out CAT's machine learning or data science grade, right? We find out the close one could be this one, this guy, right? Davy also take the course 1 and course 2 with the same grade, right? We're going to say we may imagine that K should have the similar machine learning or data science grade in the end. Okay, so that's what we call closest student. Okay, oh, actually that belong to what? Belong to the K nearest neighbor. Okay, K nearest neighbor. So K nearest neighbor. Okay, nearest neighbor means okay, if you want to pick up, some data points, what kind of label that this data point have, right? So we're going to consult somewhere nearby, right? Could be, okay, there'll be some blue circle right here. Could be some green circle, green cross right here. Okay, so we're going to say, for instance, if the blue circle right here is the nearest, right? So we're going to say, okay, this new data should be blue. Okay, should be blue. On the other hand, we can also try k nearest neighbor means that, okay, we can actually consult more than just one, right? We can consult a few of them if they consider to be close, right? Then we can make a different judgment, okay? So here maybe we already considering 5 nearest neighbor, right? 5 nearest neighbor. So which means the k could be, it's up to us what kind of value uh, we should choose, right? So for different k, the result could be different, right? If we choose k to be maximum, meaning that actually we use the majority to from the whole piece of data to make the final judgment. Okay, so that's where that we can build our model. So in the end, after that we have the model, right? And then we can wait until end of this course to know, okay, would this model be to be good enough, yes or no, right? On the other hand, we can also try something like what we call validation, right? Validation. Okay, validation. So validation is that where, okay, so suppose we have a whole piece of data, right? So actually we use this part to be the real training data, right? And use this part to be the validation data, okay? Validation data is actually, we know the label, just we pretend that we don't know, right? And we use a small piece of the data, a subset of the whole labeled data to build a model. And after that, we try to predict what we can get on this validation set, right? Okay, so if we can get a good performance on this validation set, we say, okay, that'll be good enough. We say the model will be good enough, right? Okay, so that's why we can rely on, the training and the validation. Here should be validation set, right? So and then we can know the classifier or the model will be good, yet good enough, yes or no. In the end, okay, so when we have a good model, right, we're going to say, maybe we can reuse model for a while, right? But if the model is not good enough, we're going to question a lot, like, okay, could be the representation is not good enough, right? Could be the assumption, like we assume the students' work could be in groups, right? Could be that give us some slightly different result. So we rely on different evaluation method, okay, to give us the answer, like we want to stick with the same model for a while, or we try to reconfirm or refine the model given more and more data. Okay, so here is the final slide for this part of lecture. So we try different disciplines from statistics, visualization, data mining, and machine learning to give us a rich set of methodology to help us for data science or to solve data science problems. Okay, if we focus on machine learning problems, right? So maybe we're going to have a supervised learning, unsupervised learning, and reinforcement learning, and even semi-supervised learning. They can give us different methodology, different set of tools to use. If we focus on classification problems, we should pay attention to different steps, like starting from collecting data, make assumption like finding representation and build a model, evaluation for the build model, and after all that we want to make sure that the model is good enough, yes or no, right? And from time to time, we're going to see, let's say, people may make mistake, right? So usually people will question is himself or herself, right? Maybe they choose the wrong model, right? But actually, all kinds of situation could happen, such as other than the, writing the wrong codes, right? And you may also pay attention to, let's say, for instance, maybe you don't have a good assumption, right? Maybe you didn't transform the data to be the right way, or maybe the data could be noisy, right? All these kind of things like garbage in, garbage out, right? Right? All these kind of things could be affected, could be influence the result, affect the result. Be affected, could be influence the result, affect the result, right? So you need to be have experience, more experience to make sure that when you don't receive a good outcomes, right? So you don't just question, the model is not appropriate, right? You also pay attention to some other possibilities, right? So that's something that you should keep in mind. Okay, so that's all for this part of lecture. So hope you enjoy it.